without further ado, so let's ask ourselves, what is data science? Because that's where we're taking this from. What is data science? Then what are the data science tools? Then we'll take a little bit of introduction to NonPI. So I have a little bit of quiz for us. I'm going to paste the link to the quiz now. So I encourage us to please take it. It's not going to last for a long time. It's just there are going to be maybe 1 or 2 minutes. Yeah, 1 or 2 minutes. Just a moment, I'm trying to post the question. Okay, so I just posted the quiz question to the chat. So if you can see it, kindly click on it and attempt the questions. They won't take long, just 1 or 2 minutes. I'm going to allow 1 minute more. So it's quite trivial, just attempt it. It doesn't matter whether you're correct or not, it's not going to count towards anything. So it's just a knowledge-based quiz. I'm going to be sharing the everybody's response without their names, of course. So we can see the answers filtering in. Keep them coming. We have 3 people's answers already. So we can see so far 3 people think, 3 people, the question, when did you first know about the term data science? So 3 people have responded. 1 person knew it by 2019. 2 people knew it between 2015 to 2018. So let's keep it coming. So let's keep it coming, everybody. Okay, we'll go back to it. Now let's take a little bit of history. I'll start with this quote. The ability to take data, to be able to understand it, to process it, to extract value from it, to visualize it, to communicate it, that's going to be a hugely important skill in the next decades. This quote is attributed to Hal Varian, Chief Economist at Google and UC Berkeley, Professor of Information Sciences, Business and Economics. This quote was made by Professor Hal Varian in the year 2009, just about a decade ago. And if you look at what the trend is at the moment, what the buzz around data science is at the moment, you will quite agree with almost everything, if not everything, Professor Hal Varian has said here. Almost every company is scrambling for data scientists now, and for good reasons. So now let's move on. Before the turn of the millennium, the term data was only sparingly used. However, since the turn of the millennium, there has been a rise in the practice and use of the term. So let's check out some timelines here. In 96, with the year that marked one of the earliest mentions of the term data science, it was mentioned in the context, in the title of a meeting, a conference by members of International Federation of Classification Societies, IFCS for short. They made a mention of the term data science in the title of their conference, in the theme of their conference, and the theme was data science, classification, and related methods. In the year 2002, so there was another mention of data science. These are not, the mention of data science are not limited to this timeline that I've provided here, but I just put them here for academical purpose, just to just get a little bit of history. The list here is not exhaustive. So, launch of Data Science Journal, publishing papers on the management of data and databases in science and technology. It happened in the year 2002. In the year 2009 was when Professor Hal Varian made the infamous quote I read above, and this is a more detailed, a more comprehensive extract of his words. Okay, so you might have been asked, or you might wonder, what is the definition of data science? What constitutes an ideal definition? If you've been exploring data science before now, you might have asked that question on Google, or you might have asked to somebody. So here, let's look at some explanations or definitions that describe what the term data science is. Data science is said to be an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. Data science is a concept to unify statistics, data analysis, machine learning, domain knowledge, and their related methods in order to understand and analyze actual phenomena with data. So, however you want to define data science, you will agree that what is here quite covers what data science represents. First, it is said to be interdisciplinary because it takes a little bit of statistics, algorithms, programming, and domain knowledge. You can call it business knowledge or field knowledge, however you choose to call it. So, I left some references here just in case you want to read more about some of these things. So I got this from Wikipedia. Now let's check out some associated fields of data science. The following fields are all related to data science, and practitioners of data science can find themselves doing any of it. Statistics is the first on my list, and it's a no-brainer. It's about one of the first things that will cross everybody's mind. So when you talk about data science, you talk about making use of data, usually in large form, and trying to draw meanings from it, and it draws a lot of parallel with statistics. Then you can talk about machine learning. So if you find yourself doing machine learning, you can as well call yourself a data scientist, or predictive modeling, or data analysis. If you find yourself making visuals, trying to present a large pool of information in a condensed and concise way, then you can as well call yourself a data scientist. Data visualization is a little bit synonymous to data analysis, because in data analysis, you might just need to prepare your data before visualizing it. But anyway, if you're doing data visualization, you still have to prepare your data. So we have data mining. It is a class, or it's a field of data science that involves drawing valuable meaning from very large pool of data. So running statistical inferences or statistical techniques on large amounts of data and trying to draw inference from it. Now we have clustering and cluster algorithms, where you try to arbitrary records or arbitrary items, you try to group them based on similarities without any prior information other than the attributes of the data that you have. Then we have artificial intelligence. Pretty much everybody who is literate would have heard about artificial intelligence, and that is like giving intelligence to machines. So it is also an aspect or a subdomain of data science. Then we have mathematical modeling. Mathematical modeling, just like statistics, has been around for a very long time, and it's age-long, basically. It's age-long, and people have always been modeling things mathematically and trying to use that technique to better understand situations in life, in their surroundings, and so on. Then we have big data analytics. Big data analytics. Today we're in the age where data is churned out in millions and trillions in seconds. I can imagine that between the time I mentioned big data analytics and now, in the world, probably the size of data that has been generated is already more than 1,000 terabytes in the few seconds between the time I mentioned big data analytics and now. So I can imagine that probably terabytes, thousands of terabytes of data has been generated. That shows the rate at which data is being generated in this day and age, from the data that is being mined on social media to the data that is being generated by sensors that are used to monitor our surroundings, and so many others. So then we talk about deep learning, which is a field of data science that's started gaining momentum at the turn of the century as well. So deep learning is a field that tries to model situations or model run predictive models basically on by using very deep network, very deep, they call it neural networks. So making use of deep neural networks in order to run predictive modeling or classifications or reinforcement learning and so. So here, next on the list we have reinforcement learning. It's a class of data science where machines tries to learn on its own about its surroundings without being taught. So think about a machine being allowed to play a game like Super Mario. Most of us may be able to relate with Super Mario game, or probably Tank, for instance. So games such as this, imagine a machine being able to play such game without human intervention, without being taught to play it, without writing any algorithm that teaches the machine to play it. The machine just starts randomly and over time learns what is right, what is wrong by what is called punishment and reward system. So then you talk about data engineering, which deals with the process by which you set up pipelines for data science. So where science process to extracting the data, passing it through the model, then serving it to the production server. Then that is what data engineering is about, and that is also a field of data science. Then we have business intelligence, and there are many more. So anybody who practices any of the above can be called a data scientist. So now, data scientist stack. As a data scientist, what are the things you need to learn to become an accomplished data scientist? So what skills do you need? So there's this general saying that a data scientist is someone who knows just enough programming, Python or C++ or Java or any other, then knows enough statistics, as well as have enough domain knowledge. And when I say enough, I mean just enough. It doesn't have to be the best statistician, it doesn't have to be the best programmer, it doesn't have to be the person with the most vast domain knowledge, but is able to combine ample amounts of these three areas together, and that is what makes a data scientist. Okay, so we move on to the other aspect of today's class. We're done with the introduction to data science. Now we take NonPI basics. So what is NonPI? Before I go to defining what NonPI is, I'll mention that this course assumes that you have a background knowledge of programming, at least maybe Python programming or C language or Java or any programming language for that matter. So it assumes that you have foundational knowledge of any of these programming languages. For that reason, we wouldn't be taking the most basic programming concepts. Okay, so what is NonPI? NonPI stands for numerical Python. It is an abbreviation that combines numeric and Python together. Okay, so it is a Python library that supports a very large multi-dimensional arrays and matrices. It also offers a large collection of high-level mathematical functions that operate on these arrays. We'll understand better what this means as we proceed. So let's start with installing NumPy. To install NumPy, you have to run the command pip install. This assumes that you already have a Python interpreter running on your system. So if you have a Python command prompt and you run pip install NumPy, the highlighted part of this of this text. So once you type pip install NumPy, then you press enter and you wait for it to install it. So let's go to the basics. What is an array? An array is said to be a grid of values. So when you talk about grid, what comes to your mind is matrices, where data is arranged into rows and columns. So when you think of NumPy, you should think of matrices. But the edge NumPy has over ordinary matrices is just two-dimensional, which is just the horizontal dimension and the vertical dimension, whereas NumPy gives you the power to represent multi-dimensional data. So you're not limited to just two dimensions. You can have three dimensions, and you can theoretically have unlimited number of dimensions, as much as your compute can hold. So it also ensures that the grid of values, all of the grid must be of same type, ideally, and is indexed by a tuple of non-negative integers. So you will hammer further on what this part means. It is indexed by a tuple of non-negative integers. So creating an array. An array can be created from a list and its values accessed by indexing. For instance, assuming we have an array named array, as is here. So, and you type what I have here, this is going on the third item in that array. So far, we haven't seen what a NumPy array looks like, and that is what we will be looking at next. So in order to create an array in NumPy, I just saw the chart. I don't know when it came in. Is it any better? I need people to confirm if it is any better. Take you from the aim of the show, taking you from take you from the aim of the show, taking you from take you from the aim of the show, taking you from take you from the aim of the show, taking you from take you from the aim of the show, taking you from aim of the right from aim of the draw inference from aim of draw inference conditions. That's your forest draw inference conditions. So 1% I welcome everybody in here. So I welcome everybody in here. Sorry. Table of contents. This program you will read 5 components. This program you will read 5 components. Here we have which is we have I got a message that audio is not here. So raining here and audio is not here. Let's see raining here and audio is not here. Let's see raining here and as soon as it gets here, it's carrying everything. Here, as soon as it gets here, your phone carrying everything. As soon as it gets here, it's carrying everything. Okay. As soon as it gets here, it's carrying everything. Okay. As soon as it gets here, content carrying everything. Okay. As soon as it gets here, content carrying everything. Okay. As soon as it gets here, content the other one is this one. As soon as it gets here, content carrying everything. So when it gets here, what is you are thinking? Okay, so when it gets here, content carrying everything. Nobody actually chose a ground staff meter working out, and this happens. A ground staff is strongest. Okay, so actually ground content working out. So today we discuss something the fact that data science today I am contained data data science today non-contained and data shows today non-contained tomorrow we will try to be like As soon as it gets better, just let me know. Years. Two people said over 50 years. Well, I won't say anybody is wrong or anybody is correct. It has always existed, different names. It has been practiced in different ways. People that do statistics can be said to be doing data science, and statistics is an age-long. Okay, so I still await your feedback on whether the voice is getting better or not. Okay, so the last question here is, in one sentence, what do you hope to learn in this course? Okay, so we have 4 responses. So one person said, so I want an increase. I'll just continue to read the table of contents. As soon as we learn how to mine, present, somebody please let me know. Data. Another said, I want to learn more. I've been receiving feedback that another person said, the audio is not clear at all about analyzing data with Python. As much as possible, we're going to meet everybody's expectation. Thank you for providing your feedback. Okay, so while I wait the feedback as to whether my audio is better, I'll just continue to just say repetitive things. So here, the first thing to do is to import the module. Okay, so I got the feedback that it's much better now. So I'm giving it I guess we can move NP. Alright. I can as well import it without giving it an alias. It's more without further NP than writing NonPI repeatedly in full. So I have imported. Let's ask ourselves, what is data science? The audio is better because that's where we're taking this from. What is data science? Okay, so and what are the data science tools? Then we'll take a little bit of introduction to NonPI. So I have a little bit of encourage people to make use of this. I'm going to paste the link to the quiz now. Very often. So this help function is able to encourage us to tell you about a method or a function. It's not going to last for a long time. How the function can be used. Sometimes it will give the example of its usage. So let's see. There are going to be maybe 1 or 2 minutes. So let's call help on NonPI and see just a moment array, MP the question and see what gets returned. So here we have help on built-in function array in module NonPI. So it tells you that okay, array, this is how it is called, then you pass in some parameters here and it explains, it gives you the names of the parameters you're passing in. So here we have 6 parameters, I beg your pardon, object, dtype, copy, order, sub OK, and nd min. So it tells you that this function or this method creates an array, and it tells you that these parameters, these are the things these parameters accept. So here it tells you the first parameter, object, accept an array-like object. So this tells you can't pass in an object that is not array-like. So you can't pass in a scalar object, for instance, a 2, just 2 as the object here. No, it has to be array-like. For instance, it has to be a list. A list, if you're familiar with list before, you'd see this looks very familiar. This simple list, that's the object that I'm passing in here, the object you have here. So and it creates an array and passes it to this variable a. So let me run it. Sorry. So we see what it produces. So I have 4 print statements. The first, print the type of the variable, simple one-dimensional array, just like a vector. You think of a vector where you just have,
it's quite trivial, just attempt it
here. A one-dimensional.
It doesn't matter whether you're correct
you
or
don't
not.
have
It's not going to count
records spanning along the
it's just the knowledge.
It's just one row of record with 4 columns.
I'm going to be sharing everybody's response,
just one dimension, and
without the name, of
has 4
course.
items in it. Then here I call .dtype to tell me the type of data that this array is storing, and it tells me it is float 64.
So we can see the answer
different
in
data types. Probably we'll discuss it in the next class. It's not, it's out of today's scope. So there's float 32, there is float 16, and others. So example 2, creating a 2D array, a 2-dimensional array. So what do we do differently here? It's basically a list of lists. So here we have our first square bracket that creates a list. Keep them coming. We have 3 lists and has already 2. So we can see so far 3 people think, we can call this,
list 3 people. The question, when did you first know about the term data science?
Creates an array out of it.
3 people have responded.
What it gives.
1 person knew it.
So we still run the type
by 2019.
NumPy ND array.
2 people knew it between 2015
the function,
2018.
the method. So let's keep it coming. Print the object itself, and it gives us a grid formatted array. So here we have 259, which is the first list in the.
So let's keep it coming, everybody.
316, the second list in the bigger list. So
okay, we'll go back to it.
And here we see that the shape.
So now let's take a little bit of history.
2 by 3.
Outside of this code,
2 by 3.
The ability to take data, it can be able to understand it,
the bigger list
process it, to extract value from it, to visualize it, to communicate it.
Another item.
That's going to be hugely important
of it as
in the next
one
decade.
And this is another row.
This code is attributed to Hal Varian,
of
Chief Economist at Google and UC Berkeley,
in the column
Professor of Information Sciences,
on the column
Business and
3
Economics.
This is the first. 2 and 3.
This code was made by Professor Hal Varian in the year 2009.
Int 32. So they can
Just
also
about
be
a
int
decade
64.
ago.
They can be int.
And if you look at what the trend is at the moment, all the buzz around
as well.
So this data science is at the moment, you will quite agree with
we want to
almost everything, if not everything,
that
Professor Hal Varian has said here.
So it can take a D-type argument. So the one
almost every company is scrambling for data scientists now.
So it's
and
just
for good reasons.
It tries
so
to
now
guess
let's
what
move on. Before the turn of the millennium,
let's look back here.
The term,
in this example, we didn't specify that
the term data was only sparingly used.
We've created a float data type.
However, since the turn of the millennium,
decimal
there has been a rise in the practice and use of the term. So let's check out some timelines here.
It infers that this is
in 96
float 64 data type.
With the year that marked one of the earliest mention of the term data science.
NumPy
it was mentioned in the context.
There can be times when
it was mentioned
sometimes for
in the title of a meeting, a conference by members of International Federation of Classification Societies, IFCS.
Out of scope of
they made a mention of the term data science in the title of the conference, in the theme of the conference, and the theme was data science, classification, and related methods. So here, we're passing the year 2002 as the data. So there was another mention of data science. These are not. the mention of data science are not limited to this timeline that I've provided here. I put them here for academical purpose, just get a little bit of history. They are not, the list here is not exhaustive. So, launch of Data Science Journal, publishing papers on the management of data and databases in science and technology. It happened in the year 2002. In the year 2009 was when Professor Hal Varian made the infamous quote I read above, and this is a more detailed
a more comprehensive. I just got a feedback that somebody extract of his audio. It could be from my end. Okay, so I need others to please. You might have been asked, or you might wonder, what is the definition of what constitutes an ideal definition? If you've been exploring data science before now, you might have asked that question on Google, or you might have asked to somebody. So here, let's look at people are explanations or definitions that describe what the term data science is. I don't seem to know what the source is. Data science is said to be an interdisciplinary field that uses scientific methods, processes, algorithms, and systems to extract knowledge and insights from many structural and unstructured data. Data science is a concept to unify statistics, as soon as we get data analysis, machine learning, domain knowledge, and their related methods in order to understand and analyze actual phenomena with data. So, however you want to define data science, you will agree that what is here represents. First, it is said to be interdisciplinary because it takes a little bit of statistics, okay, I'm sorry everybody, I left another video playing in the background, so I just fixed that. Thank you for drawing my attention to it. I apologize for what everybody has missed so far, so I'll try to just go back and do a recap. So what is NonPI? NonPI stands for numerical Python. So it's just a Python package which carries out numerical operations in a very effective way, very large data, multidimensional data especially. That's actually the beauty of NumPy. So think of as just that matrices is just a two-dimensional unit, or is the building block of NumPy, representation of data in grid format. So it is said to be a grid of values, all of the same type. That's very important, because that's the only way NumPy will be able to efficiently store this data. If there are different types, then the efficiency you can get with using NumPy can get reduced. So it has to be of the same type, the data you're storing. And they are indexed by a tuple of, they can be accessed, is indexed by values which can be accessed by indexing. So you can access, just like you can access lists by the index of the items in a list, you can access items in a NumPy array that way as well. So this is, so I'll continue while I wait for response. I just sent a chat for people to respond. Okay, so the first thing to do is to import NumPy as MP, and I made mention of, I may see examples here. So here they are. These are some examples showing how to make use of NumPy array. So without anybody teaching you, by simply calling help on MP, a full grasp of how you can make use of MP.array. In fact, I think it's even more comprehensive than what I put here. Although what I put here is just not to overburden everybody with too much information, since this is just the first class. So you can as well study this. Additional knowledge can be gotten from it. So let's move on. Now, creating a 1D array here. So you simply pass in a list. This is a list here of 3.0, 1.0, 4.0, and 0.0. Pass it in into the mp.array method, and it creates an array. Then I use this type function to get the type of object that this A is, and it rightly tells me that it is a NumPy ND array. ND here means n-dimensional, meaning this can represent, n can be any arbitrary number. It can't be 0 of course, but it can be 1 and it can be millions. Basically there's no limit what it can be. Okay, so print A, and this prints out the object, the array object, and we can see here it is 3 1 4 0, and we can see a point after it telling us that it is not an integer, it's not an integer type array, it's rather a float type. And what float type? This tells us it is float 64. And the shape method here tells us the shape of this object. So it is just a one-dimensional object of size 4. There are just 4 items in it. You can as well get the size of it by printing a.size, which should also return the same 4. The difference between size and shape is size flattens out your array grid before telling you the number of items in it in total. We'll use it more as we go ahead and you get better understanding. Okay, so here we create a 2D array by calling mp.array and passing a list of lists into it. So here we call type and it tells us it's a NumPy ND array. Here we print it out and we see it nicely formatted, just like a matrices grid. Yeah, so a matrix grid, 2 5 9 as the first row, 3 1 6 as the second row, and there are 3 columns, 2 and 3 column 1, 5 and 1 column 2, 9 and 6 column 3. Although Python is 0 indexed, so it would rather be called column 0, column 1 and column 2, and row 0, row 1 respectively. So this tells us the shape is 2 by 3, this shape method, and the d type tells us it's int 32. We can see that here we didn't tell Python what type of data type we're passing in here. It simply infers that this is an integer and it assigns it int 32. You can as well explicitly state what integer type you want it to be inferred, or what data type. So for instance, I can pass the d type argument and say I want it to be int 16 and run it. Oh, sorry. So mp.int 16, and we see that here the data type has changed to int 16 from the original 32. Because it was left to infer what data type it is, it simply assigned 32. Right, so moving on, example 3, specifying the data type parameter. I've shown the example here. This is another example where we're passing in the complex as the data type. So here it simply returns a complex complex items inside the array. So array indexing. Okay, this program is scheduled to finish by 5:59. 6 o'clock, I beg your pardon, and it's 5:50. List which houses 3 other lists in it. So each of the lists have 4 items in them. So we can say the first list has 3 items. And the sub lists have 4 items each. So that already tells us the shape. So here we print the shape. Here we print the array itself. So here we try to get the first item in this list. And here, okay, yeah, the first item, which is the 0th item, the second, which is the 1st item, and the third, which is the second item. And here we try to get the 0 indexed item in the bigger list and the second index or the 2 indexed item from the list we have gotten. Okay, once I run it, it becomes clearer. So here, the first thing we did was to get the shape 3 by 4. It has been explained, and this is simply printing the array. So we can see how it it has nicely formatted it. So this is the bigger list. This is the square bracket that marks the start, and this is the square bracket that marks the end, and we have in it 3 other list items. So each of them having 4 items in them. So here we said we want to get the first item, the 0th item, 0 indexed item. So it is the 7462. Then we want to get the 1 indexed item. Then it is 2, 3, 4, 9, and the 2 indexed item. And so what we did here was to say, okay, we want the 0 indexed item from the outer list. Then from when we get that, okay, let's see what's the 0 indexed item. That is what we have here. This is the 0 indexed item, as we can see from this print statement. Print array 0, 0 index. So it gives us this. Then in this list we say give us the second 2, right? Give us the second, and the second is, or let me say the 2 indexed item, not necessarily the second. So 0, 1, 2. So this is the 2 indexed item. So and that is 6. So the first index we passed here first gets the, let me say, gets the first row. Let me make use of rows now. That may be a little clearer to us. So gets the first row, and in this first row, this 2 here gets the 2 indexed item in the first row and gives us 6. So here this is just showing you how what this 6 I got here, an alternative way it can be gotten. So instead of doing it this way, we can as well do it this way. First getting the 0 indexed item, and then getting the 2 indexed item from the 0 indexed item. So and I'm asking Python, is this equal to this? And it tells me true, yes, it is equal, or they are both equal. So creating arrays from functions. So NumPy is so powerful. It allows you to create arrays without having to type out the array, especially if the array is quite uniform. So think of this. Assume you need an array of zeros, just zeros. You want zeros, or let me say you want a range of numbers. You want an array, yeah, you want an array of 1 to 100. So instead of having to type out 1, 2, 3, 4, 5, 6 to 100, and now passing it into your np.array function or method to create an array object, so you can simply build built-in functions that do that for you. In fact, if you need to just create arbitrary arrays that have certain patterns to them, there is almost certain that there is a NumPy function or a combination of NumPy functions that can do that for you. So here we call np.arange. If you're familiar with range function from Python, this is not much different. The difference is just that you're calling np and you're saying arange instead of range that you know in Python. So range, the same way range works is the way arange works in NumPy. So what it does here is it creates a range from 0 to 10, and it just steps it by 1. So let's run it and see what. So you can see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Always remember that the last item would never get returned. But if you count the number of items in this array, it is 10. Excuse me. So here, the default step is 1. We didn't specify the step. This is the function. Arange start 0. Stop 10. Step is defaulted to 1 since we didn't pass anything. As well, if we don't pass start and stop, it's still going to work fine. So we can see I removed the start. It's going to assume that the start is 0 if you don't pass start. So you can get away with not passing start to it. You can just say 0 to 100. Let me put 100, and it gives you numbers from 0 to 99. So here I'm passing the number of the steps I wanted to take for each number is generate. So I'm passing the step of 2, and I'm saying give me numbers between 5 and 15 and step them by 2. And here you have 5, 7, 9, 11, 13. Okay, so another helpful function is np.zeros, to create an array of zeros. So this is how the function looks like. Shape, you pass in the shape, you pass in the data type, and you pass in the order. So this is out of the scope. This order argument is out of the scope of our discussion, but you're already familiar with D type. So the default D type for creating np.zeros or NumPy zeros, for using NumPy zeros function, is. So here we create np.0, we create an array of zeros of 3 by 4 shape. So we want the shape to be 3 by 4. So we'll print it out, and the other one is we want it to be 3 by 2 by 4, and we also print that out. So let's go. So this is the first, a 3 by 4 array. We can see it, 3 rows, 4 columns of zeros, all zeros. And the other one, which is 3 by 2 by 4. So let's see it nicely formatted as well. So here we have 1. Let me mark it. 1, row 2, row 3, right? So within row 1, or let me say dimension 1, because if I see a row and column, when it gets to 3 dimension, you no longer know which is row, which is column. So I would rather say dimension 1, dimension 2, and dimension 3. So in dimension 1, we have 2 dimensions in it, or let me say 2 items in it. So, and each item, or let me say each dimension is a 2 by 3 NumPy array as well. Yeah, that's a better way to put it. So each item in dimension 1 is a 2 by 3 array. Dimension 2 is also a 2 by 3 array. Dimension 3 is also dimension 1, but first item, second item, and third item. Pardon my wrong or my misuse of adjective there. So when I say dimension 1, I'm referring to this, and this. So consider them as dimension 1. Then if I now go to each of them, so I pick this now. This one has 2 dimensions to it. The first dimension I'll highlight is this. These are the first dimensions. And the second dimension is from each of them. So this one we picked here also has 4 items in it. So if we take the shape of this alone, the shape is just 4. If we take the shape of this, the shape is 2 by 4. And if we take the shape of everything, the shape is what? 3, which is 1, 2, 3 by 2. Each of them has 2, right? Then by 1, 2, 3, 4. Each of them has 4. 1, 2, 3, 4, 5, 6. Each of the 6 have 4 items in them. So the shape is 3 by 2 by 4. So another example here, we can create array of ones. So let's run it and see. So we'll create array of ones of shape 4 by 5. And here it rightly gives us 1, 2, 3, 4. And each of them has 5 items in it. 1, 2, 3, 4, and 5. So at this juncture, we have come to the end of today's session, and I'll leave the comment section open for questions. Questions haven't been coming in as the classes were as the class was presented, but I assume if you have questions, you should be able to ask it now. Since and for subsequent classes, if you have any question, if any part of the class is not clear to you, you can post your question. You won't be interrupting anybody by typing your question into the comment box. So I'll see the question and I'll try to answer it as soon as I see the question. I'm waiting for questions to be asked. Ask questions, everybody, ask questions. Okay, in the absence of any question, I think we can bring this class to a close.